Mr. Lee here. All right, so this practice involves restricting domains of functions to make them invertible. Okay, we'll explain what that means exactly. I want to kind of have you read this question first, and then I'll show us a quick lecture, and then hopefully it'll help us then come back to these questions and answer them. Okay, so we have function f, graph below, is not an invertible function. To which intervals could we restrict the domain of f to make it an invertible function? Huh? Okay, so what it means to be an invertible function is if I have some relationship, if I have some function, and then I graph its inverse, is that inverse also a function? Okay, so this video, this practice actually requires you to know what a function is. Okay, just as a quick reminder, any function, a function is any relationship where every single x value matches with exactly one y value. Okay, so if you remember, there's something called the vertical line test that helps you test if a graph is a function. I'm going to switch screens here. Okay, we're going to come back to this, but make a note that we're trying to figure out how to make a specific relation an invertible function. Okay, so reviewing a little bit, right? I'm going to start with just a parabola here. Okay, we have a quadratic. This is a type of function. Okay, it's a type of function because it passes the vertical line test. Vertical line test tests a relation as a function. If I can draw a vertical line anywhere through this parabola or this relation, and it only hits one point at a time, then that means it's a function. Okay, that's another way of saying, oh, every x value hits exactly one y value. Okay. Now, if I graph its inverse, right, this is the inverse of the parabola. Notice how this inverse now does not pass the vertical line test. Okay, so this is where we have a problem. In order to make the inverse, which is shown here in blue, in order to make this inverse an invertible function, it has to first be a function. Okay, so it fails the vertical line test, so this inverse is not a function, even though the original function was, right? Original function was, sorry, original relation is a function, okay? But then once I invert it, the inverse is not a function because it fails the vertical line test, right? So this is what we have to do, okay? We have to restrict the domain so that when we graph the inverse, it will then pass the vertical line test. Okay, so I'm gonna start with here. If I'm able to cut off half the parabola, let's say I just want to do x is greater than or equal to 0. Okay, so I'm just showing that right side of the parabola. Right, it's still a function. Right, passes the vertical line test. And its inverse now will look like this. Okay, so before I did any of the restrictions of the domain, the inverse in blue was not a function, right? Because it failed the vertical line test. Now it passes the vertical line test, right? So that is how I successfully made your original equation invertible. Okay, because its inverse is now a function, right? So that's me adding a domain restriction, right? Restricting the domain to make that happen. All right. So now we're going to backtrack a bit. From the very beginning, there's this thing called the horizontal line test now. Okay, you probably saw it typed up here, but I'm going to explain it further now. Okay, let's say I start with my original function again. A horizontal line tests horizontal line test tests if a relation's inverse is a function. Okay, so I'm going to draw a horizontal line now, and it kind of has the same rules of your vertical line test. If it hits more than one point, like as you see it does here, right? I can stop right here at a y value of 4. It hits one point there and another point there. So it fails the horizontal line test, which means its inverse cannot be a function, right? And we can prove it once more, right? I'm going to graph the inverse, and its inverse with the vertical line test is not a function. Okay? So that's the nature of taking the inverse of a vertical line, right? Vertical line test for a function. If you're now testing or taking the inverse of a vertical line, you get a horizontal line, right? So we can now use that on the original to test that the inverse is a function. Okay? So let's go back to the original. Now I'm going to show the restrictions. Okay? With the restrictions, what did we have? We had x is greater than or equal to 0, right? If I change the domain to just show this half the parabola, and then I do the horizontal line test now, it will pass, right? It does pass the horizontal line test because it now only hits one point at a time, which then means its inverse should be a function now. Okay, so that's the inverse in blue. I restricted the original red function. And now the inverse passes the vertical line test. Okay, so all in conclusion, if in the very beginning your original function passes the horizontal line test, that means its inverse will be a function. Okay, if it doesn't pass the horizontal line test, like this one fails it, then its inverse will not be a function. Okay? Okay, so I know that was quite a bit to hear. Rewind it if you need to. But let's get into some of these problems now. Okay? So hopefully this makes more sense. Function f, graphed below, is not an invertible function, right? Because it fails the it fails the horizontal line test, right? I can draw a horizontal line right here. It hits more than one point. So when I invert this whole thing, its inverse has no chance of being a function. So it starts off as not invertible. That's what it means, okay? To which intervals could we restrict the domain of f, this is f, to make it an invertible function? So we're trying to see which intervals, which pieces of the graph do pass the horizontal line test, right? If we just consider that section, if we restricted the domain to just that section, and it passes the horizontal line test, that means its new inverse will be a function, meaning it's invertible. Okay, so we have to go through each one of these, choose all that apply. Between -1 and 1. Okay, so x value between -1 and 1. I'm looking between here, between -1 and 1. I'm looking at this short piece. Okay, it's a short piece, but it's kind of an upside down parabola. We do see a vertex. This little section, if you draw a horizontal line through any part of it, it will fail, right? It's going to hit more than one point, right? So to which intervals could we restrict the domain of f to make it an invertible function? This is what we do want to click, right? Because if we... No, sorry. We don't want to click it. I misinterpreted the question for a second. If this was the only part of the graph we saw, its inverse would not be a function because it fails the horizontal line test. So we're not going to click it. Sorry about that. Okay, for the next one, between -5 and 0, let's see if that passes the horizontal line test, right? So we're just taking each section at a time. So between -5 and 0, for x values, I start -5 here, I go all the way to 0 here. So between -5 and 0, right? Use your visual skills here. I do have this portion, which passes the horizontal line test, but then it fails it when I incorporate this extra piece. So that also fails. Okay, so that won't work either. What about between -1 and 0? Between -1 and 0 is just this piece. Okay, between -1 and 0 is just this piece now. It only goes from here to here, right? Follow my mouse carefully. It's just from here to here. If you're only looking at that little piece, this little piece does pass the horizontal line test. Okay, you have to ignore everything else, but just this little piece. If you were to isolate it and draw a horizontal line through it, it would only hit one point at a time. Okay, so if I restricted this whole thing to just show the interval -1 to 0, then we'd be good. All right. So this is gonna be a slightly longer video, but stick with it here. I'm gonna show some more examples. Okay, use what you need again. Once you get the hang of it, Shouldn't be too bad. Okay, to which intervals could we restrict the domain again to make an invertible function? So we're focusing on specific intervals, okay? So let's look at between -2 and 0. Between -2 and 0 is this whole piece. No way. Okay, you have two of these curves going from the top to bottom. You draw a horizontal line through it. It's going to hit more than one. So A is definitely not good. We have a smaller interval here. We might have a chance. So between 0.25 and 0.75. 0.25 is about here, and 0.75 is here. So just this little sliver, right? Between these two x values, I am constantly just decreasing, right? I have this little portion here. Follow my mouse as close as you can. Between -0.25 and 0.75 is just this little section. So if you isolate just this little section, we're good. It will pass the horizontal line test. It only hits 1 point at a time. What about -1 to 1? -1's all the way here. -1 is all the way here. So again, between -1 and 1 for x values, we have two of these curves repeating itself. That'll fail the horizontal line test. Okay. Okay, same question. I'm not going to repeat it, but let's check each interval. New function. Between 0 and 6. Between 0 and 6 is a bigger interval. We have half of this, we'll call it a curve, half of this curve, and then repeating. So it'll fail the horizontal line test at the top portion here, right? It's going to hit more than 1 point between x values of 0 and 6. Keep following my mouse as best you can, okay? So that won't work. You don't want to choose option A. What about between -2 and 2? Between -2 and 2, I think we're good. -2 and 2. Okay, so this gets a little dicey here. We want to include the -2 because we have an equal sign here. We don't want to include the right bound 2, which means we're literally going from this endpoint to this open circle. Okay, we're not including this closed circle. That would actually pose a problem with the horizontal line test, right? Because it would hit these 2 points. But because I don't have an equal sign here, I'm actually stopping at this open circle. So if I'm just considering this curve between x values of -2 and 2, if you just isolate this one curve, it does pass the horizontal line test, right? You're not considering any of these curves on the left. You're not considering any of these curves on the right. Just this middle curve right here. So we do like option B. Option C, last one, -4 to -1. So -4 to -1, -4 starts here, -1 ends over here. Okay, so we have a y value of 0 and then positive y values. And then we have negative y values here. -1 stops here. So we're actually good, okay? Let me see if I can give a little more detail here. I'll draw a line, okay? This might help. So -4 goes here, right? And then -1 ends here. I'm trying to show the bounds. Okay, excuse my my curved lines there. But if I'm just looking at that section, okay, and I draw a horizontal line, right? This is actually a good way to show it. If I draw a horizontal line from here to here, that passes, that passes, that passes, right? I'm restricted to this new domain between -4 and 1. Okay, I'm not considering anything to the left of this green line or anything to the right of this green line because of my domain restriction. So we actually also like option C. All right. So this one, we have 2 answers that are good. Let's do one more. So again, here's what you need. I know I'm going a little bit longer here. All right, so new function, interval 3 to 5. Between 3 and 5 is just this little sliver. Okay, use your visual skills. You can draw in Khan Academy if you like to. Between 3 and 5. Your annotate button, by the way, bottom left, right? Between 3 and 5 is here, so it's going to go from approximately from here all the way to here. Okay, it's just this little sliver. If I restricted this whole function to just this section, then we should be good. It passes the horizontal line test. Next one, -2 to 2. -2 is all the way here, all the way to 2 here. So I think we're good. -2 starts at a minimum, a local minimum, and then we go all the way to an x value of +2, local max. So local min to local max, it keeps increasing the whole way. So that'll pass the horizontal line test. Okay. Between -6 and -2, let's see what we got. Between -6 and -2. Okay, so this one will also pass as well. I think I do want to just be thorough for this last one. I'll do the same thing that I did the last example. So between -6 and -2, we go from here to here, right? So sandwich in between. I want to see what's happening. Okay, so just with that domain restriction, if I draw a horizontal line anywhere through, it does pass. Passes there, it passes there, passes there, passes there, right? I'm not considering anything to the left of this green line, anything to the right of this green line. So all intervals actually match, right? So there's multiple ways to restrict the domain of a more complex function to make the final inverse an actual function, right? And that's what makes it an invertible function.